Okay, so in this video we're going to be looking at relational operators, Boolean operators, and conditional statements, and then we'll look at applying all of these concepts to a specific program. So let's get started. Alright, so let's take a look at relational operators, and probably many of you are familiar with a lot of these relational operators because you see them in various math classes that you've probably had. So the first relational operator we have is the greater than operator. So we can have this expression here to test to see if 10 is greater than 6, and that is true. So the result of this expression here would be a true value, a Boolean value. Okay, so less than, we could compare character values. So we're comparing capital C to capital A, and since capital C comes later in the alphabet than capital A, this would result in a false value. So C is not less than A since C is coming after A in the alphabet. So that's pretty cool that you can actually compare character values using these relational operators. Greater than or equal to, so in this case we're comparing 10.5 to 10.5, and we know that those would be equivalent values, so it qualifies based off of this equals here, so it is greater than or equal to 10.5 is greater than or equal to 10.5, so that's true. Less than or equal to is 5.5 less than or equal to, is negative 5.5 less than or equal to negative 100, and the answer there is false because negative 100 would be less than negative 5.5, so that turns out to be false. What about equals? So the way we test for equivalence when we're using these relational operators is not to just simply use a single equals. If we used a single equals, that would mean assignment. So we don't want to do assignment, we want to do equivalence, so we have to do equal equal. This is a very common mistake that people will make when they're first learning how to program, is they're wanting to compare two things to one another and see if they're the same, but they'll just simply use a single equal sign, and you need to use two. So we may have a string value. In this case we have high, and we've assigned it to the string variable x, and here we have high again, but this time the first letter H is capitalized, whereas here it was actually lowercase. So if we try to compare those two values, we'd find out that they were not equal, since we do have a difference in capitalization of this first letter, so that would return a false value. And then the last relational operator we have, so we only have 6 of these, the last one is the not equal to, so it's the exclamation point and then the equal sign. So if we had integer value, say A, that was assigned the value of 5, and then we have the integer value B that was assigned 12, we could see if A was not equal to B, and that would in fact be true. So that's basically it. We have 6 relational operators, and we can use them with various types of operands. We can use them with the numeric data type, so we've seen the int, we've seen the double. We can use them with character types. We can also use them with string types, and we'll see that we can also use them with other data types as well that we haven't talked about just yet. Alright, so let's look at some of the Boolean operators, and the first one we're going to look at is the AND operator. And basically it says that we have to have two things being true in order for the overall expression to be true. So we see here what we have as the truth table. So we can have some expression that resolves down to true or false for P and also for Q. But if we AND those together using our AND operator, which is this double ampersand, then in order for that whole expression to be true, then both P and Q have to be true. So we have false and false results in a false, false and true results in a false, and true and false results in a false, and then finally true and true results in a true. So maybe an example that we could think of is testing to see if someone could vote in the United States based off of their age and based off of whether they're a U.S. citizen or not. So maybe allowing P to be their age and Q to be their citizenship. So if it turns out that they're 17 years of age, but yet they're a Canadian citizen, then they would not be able to vote. If they were 17 years of age and a U.S. citizen, they still wouldn't be able to vote. Say they were 18 years of age and they were not a U.S. citizen, say they were Canadian, they wouldn't be able to vote. But if they were 18 and they were a U.S. citizen, then they could vote. Of course, this is not taking into account them being a felon and maybe being locked up in prison. That comes down to a states' rights issue in the United States, so we're ignoring that. I don't want anyone to get confused that it's only 18 and being a U.S. citizen. There are some other things, but this is a simplistic view. So that's basically it. The Boolean operator, double ampersand, we have to have both operands, both sides, P and Q being true in order for the whole expression to be true. All right, so now let's look at the Boolean operator for OR, which is two pipe symbols back to back. So that's what we have here, a pipe symbol and then another pipe symbol. And the way that you create the pipe symbol from the keyboard is to hold down the shift key and then to hit the backslash key. At least this is the case on most keyboards. So you may want to check that out. Normally it's just going to be a vertical looking symbol. It may have a break in the middle of it. It may not. But typically just shift and backslash will create the vertical pipe symbol. So what does the OR operation mean? The OR basically says that we have to have at least one of the operands being true in order for the whole entire expression to be true. So the only time we end up with a false, if we look at our truth table here, is if both operands, both P and Q, are in fact false. So an example of where we may use the OR operation is to test to see if two individuals can get on a ride at an amusement park. And maybe the stipulation for this ride is that you have to be 18 years old or older in order to get on the ride, unless you're accompanied by an adult. If you have, a kid and their parent that's 18 years of age, then the kid would be able to get on the ride. So maybe P represents the age of one individual and Q represents the age of another. So if we had, say, two, a 16-year-old for P and a 7-year-old for Q, they could not get on that ride. But if you had, say, a 6-year-old for P and a 20-year-old for Q, then they could get on the ride. Same thing here. If we had a 25-year-old and a 4-year-old, then they would be able to get on the ride. And if both of them were adults, over the age of 18 or older, then they would be able to get on the ride. So basically, the OR operation just says as long as we have one of the operands being true, then the whole expression is true. All right, so let's look at the exclusive OR operation. And the exclusive OR symbol in C++ is the little hat or a caret symbol. So the way that you can make that is holding down the shift key and then hitting the 6 key. So not the 6 on the numeric keypad, but the other 6. And the exclusive OR is very similar to our other OR, except for you cannot have both operands being true. So it says that one and only one of our operands can be true for the whole expression to be true. So an example that we may think of is two light switches that may be wired to the same exact light bulb. And if both of those light switches are in the on position, then the result of the light switch will be off. Whereas if either one and only one of those light switches is in the on position, then the light bulb will be on. So that would be a simple example, I guess, to use for the exclusive OR. One and only one of the operands can be on for it to be true. Otherwise, we have a false situation. Okay, so the last Boolean operator that we're going to look at is the not operator. So the not operator is just simply the exclamation point. And the not operator is different from the other Boolean operators in that it is a unary operator, meaning it only works on one operand, whereas the other Boolean operators they were binary operators, so they worked on two operands. And the not operator is real simple. It basically says whatever our Boolean expression is, we want to flip it. So if P is false, not P would be true. If P was true, not P would be false. So maybe P represents whether something is empty or not. So we could test to see if it was not empty by doing not P. And so that's a basic example of using the not operator. And we'll see other examples as we continue on in this series. So that's the last Boolean operator. So now we'll look at actually solving a program or a problem statement and write a program that makes use of all these, or at least some of them, maybe not all of them.